Welcome back, Physical Science 20. This is the first booklet for FC3, 12.1, What is Stoichiometry? And it pertains to pages 353 to 357 of the textbook. What we're looking at here is defining and giving an example of stoichiometry and mole ratio, identify the quantitative relationships in a balanced chemical equation, and determining the mole ratios for a balanced chemical equation. So first of all, looking at when does a reaction stop? It's when all of the reactants are used up. So when reactants are forming products, once the reactants are gone, the reaction's over. Stoichiometry, the study of the quantitative relationships between amounts of reactants used and products formed by a chemical reaction. So we're actually looking at quantity here, numbers and units. Law of conservation of mass, you would have done this in grade 9 science and grade 10 science. Basically, the amount of material you start off with must equal the amount that you end up with. The total mass before must equal the total mass after. Otherwise, you're violating the law of conservation of mass. So here I have a few examples. I'm not going to do all of them that are in the book, but we'll do some of them. So from excuse me, pages 355, 1, A to E, we'll just do a few. A is the formation of ammonia, formed from nitrogen gas and hydrogen gas in a 1:3 ratio, as you can see. And also hydrochloric acid combining with potassium hydroxide to make potassium chloride and water. Now, from these balanced reactions, you can interpret them in many different ways. 1 molecule, 3 molecules, 2 molecules. So we can talk about it in terms of molecules. These are all non-metal groups, so they are called molecules. 1 molecule of nitrogen gas combines with 3 molecules of hydrogen gas to make 2 molecules of ammonia. If we're dealing with ionic compounds, such as potassium hydroxide, we don't use the word molecule. As you recall, we use the term formula unit. So hydrochloric acid, that is still a molecule though, but formula unit, formula unit. So 1 to 1 to 1 to 1. Also, if I take 6.02 times 10 to the 23rd of each of these, we could say I have, for every 1 mole of nitrogen, I have 3 moles of hydrogen and 2 moles of ammonia. Or over here, 1 mole of hydrochloric acid plus 1 mole of potassium hydroxide yields 1 mole of potassium chloride and 1 mole of water. Now, if we know how many moles we have, we can convert that into grams, because we know the molar masses of all of these. Nitrogen gas is, for each nitrogen atom is 14, so we have 2 of them, so it's 28 grams. 1 plus 1 is 2 grams per mole of hydrogen. Nitrogen's 14, 3 hydrogens is 3, so that's a total of 17 grams per mole for ammonia. So if we take a look here, we have 1 mole of this, 3 moles of this, so that gives us 6. 2 moles of ammonia. If each ammonia molecule is 17 grams per mole, we have 2 of them. That works out to be 34 grams per mole. So if we set it up like that, 1 mole of nitrogen gas is 28 Gs, 3 moles of hydrogen gas is 6 Gs, 2 moles of ammonia is 34 Gs, and as you look here, 28 plus 6, 34, equals 34. So the law of conservation of mass holds. If we look at this side, hydrochloric acid, 1 hydrogen plus 1 chloride is 36.5 grams per mole. Potassium, oxygen, and hydrogen add up to be 56.1. Potassium and chloride add up to be 74.6. And water, 16 plus 2 is 18 grams. And look at that, 92.6 equals 92.6. So that illustrates the law of conservation of mass. The total mass that you start off with equals the total mass after. So I don't think we need to go on and do C and D, because hopefully you get the message there after the first two. So we're illustrating that the law of conservation of mass is conserved. First of all, by interpreting the equation in terms of molecules or formula units, converting it like moles, and then going into grams. Mole ratio. So that leads to this now. Ratio between the numbers of moles of any 2 substances in a balanced chemical equation. So if we look, and again here I have a few examples here. We'll only do a few though. We don't need to go through all of them. So let's say we have this 4Al plus 3O2 plus yields 2 aluminum oxide. So we could view this as 4 atoms plus 3 molecules yields 2 formula units, because look at this is a single atom, this is a molecule, this is a formula unit. Or we can read it as 4 moles of aluminum plus 3 moles of oxygen yields 2 moles of aluminum oxide. So all the possible relationships we can get from this, all the mole ratios, we can relate Al to O2, 4 moles of Al over 3 moles of O2, or vice versa, 3 moles of O2 related to 4 moles of Al. That is referred to as a mole ratio, and it'll be very important in the coming booklets. I could also relate aluminum to aluminum oxide. It's a 4:2 ratio, so I can state that as 4 moles of aluminum related to 2 moles of aluminum oxide, or 2 moles of aluminum oxide related to 4 moles of Al. And lastly, I can relate the oxygen to the aluminum oxide, 3:2 ratio, or 2:3. 3 moles of oxygen to 2 moles of aluminum oxide, or 2 moles of aluminum oxide related to 3 moles of O2. So there's 6 possible relationships I can pull out of that one equation. Here's another one. 2 moles of HGO yields 2 HGs and 1 O2. So again, I'll have 6 different ratios from relating the HGO to the HG. 2 moles of HGO related to 2 moles of HG, or flip it upside down, 2 moles of HG, etc. Or relate HGO to O2, 2 moles of HGO to 1 mole of O2, or 1 mole of O2 related to 2 moles of HGO. And lastly, I could relate these two. So basically looking at all the combinations you can have here. 2 moles of Hg over 1 mole of O2, or 1 mole of O2 related to 2 moles of Hg. So just picking out all the combinations there. Okay, vocab, stoichiometry, looks at the quantitative relationship between particles. So for example, in the formation of water, 2 hydrogen molecules plus 1 oxygen molecule yields 2 molecules of water. So 2 moles react with 1 mole, that's a mole ratio. That is stoichiometry, looking at how they relate with one another. Mole ratio, relating 2 particles together. So as you can see here, 2 moles of H2 react with 1 mole of O2, or stated the other way, 1 mole of O2 reacts with 2 moles of H2. Okay, so that is it. That's 12.1. Next we'll look at the study guide for 12.1 and see if you can do that. Okay, we'll see you soon.